Okay, good evening. This is good morning. This is Professor David J. De Los Reyes. It's August 19 already, and the time is 1 exactly 1 a.m. So it's Saturday, so my full video discussion for this morning will be, let's relax. I will just give you example problems on the topic quadratic equations that could be reduced to a quadratic equation, and that will be lesson number 36. A long video format discussion on college algebra, lesson number 36. Okay, let's proceed. The subject matter for this morning will be very relaxed, okay? So I will just give you examples. College Algebra, lesson number 36, and the title is More Examples of Reducible to a Quadratic Equation, meaning we will be solving problems that could be reduced to a quadratic equation, because the main topic is actually the solution of a quadratic equation, and one of the special forms is actually those equations that could be reduced to a quadratic equation. Okay, let's proceed with example number 1. Solve the equation. We are given x raised to 1/2 minus 6, and they should be equal to x raised to 1/4. Solution. We will let z equal to x to the 1/4. We'll let this portion here to be equal to z. So if z is equal to x to the 1/4, if we try to square both sides, z raised to second power will be z squared. X to the 1/4 raised to the second power will be equal to x raised to 1/2. We use the exponent formula here, x raised to m raised to n. This can be simplified to x raised to the product mn. So if we try to multiply 1/4 by 2, it will become 1/2. So the value x raised to the 1/2 can be represented as equivalent to c squared. So substituting now, x to the 1/2 is actually c squared minus 6. This one, we put it on the left, minus z, and this should be equal to 0. This c here is actually x to the 1/4. If we try to rearrange, z squared minus a minus 6 is equal to 0. This is now a quadratic equation. Okay? It is of the form ex squared plus bx plus c, and this should be equal to 0. For the meantime, the variable is not x, it is z. Okay? So this will be az squared, and this should be bz. Okay? If we try to bring out the solution, the smartest solution for this one, or the simplest, will be by factoring. So z squared minus z minus 6 can be factored out to the two product of a binomial, z minus 3 times z plus 6. Let's try to check the middle term. The middle term will be negative 3z plus 2z. Minus 3z plus 2z is actually negative z. This is negative z. Okay, same as this one. And the product negative 3 times c plus 2 is actually negative 6. Okay? So this is the correct binomial factors. So equating its factor to 0, z1 will be equal to positive 3, and z2 will be equal to negative 2. From the substitution or representation, z is equal to x to the 1/4. If we are computing for z1, we put the subscript 1. This is subscript 1. Then if we try to compute for x, we raise this to the 4th power. z1 to the fourth power will be c1 to the fourth power, okay, and x1 raised to the 1/4, x1 raised to 1/4, raise that again to the fourth power, and they should now be simply x1, because these 4 here cancel with this. So x1, from this substitution, x1 should be z1 raised to the fourth power, right? We computed for x here, because we eliminated that 1/4, so they should be raised to the fourth, for x to be equal to z to the fourth. Substituting, this will be 3 to the fourth power, and x1 will be equal to 81. Second value, z2 is equal to minus 2. And again, by using same formula, we just, what you call this, change the subscript. We are computing for z2, so they should be subscript 2, subscript 2. So x2 will be z2 raised to the fourth power. It should be negative 2 raised to the fourth power. And x2 should be equal to 16. That will be our answer. So the two answers, or two solutions for the given quadratic equation, or the given original equation, is x1 is equal to 81 and x2 is equal to 16. Okay, let's try to bring out example number 2. Solve the equation given x to the fourth minus 3x squared plus 2, and this should be equal to 0. Solution. We let z equal to x squared. We leave this one to be z. Okay? Squaring both sides, z to the second power will be c squared, and x squared to the second power, this should be x squared, raise that again to the second power. So again, we will still be using the equation x to the m raised to n, and this should be equal to x raised to mn. Still, right? So x squared raised to the second power will be x to the fourth. That will now be z squared. Substituting the value of z and c squared back to the given original equation, x to the fourth can be written as c squared minus 3 times the value of x squared. X squared is z, so this is z, plus 2, and this should be equal to 0. So after the substitution, see, what comes out is a quadratic equation involving z. So let's try to bring out the possible solution of this. Again, the simplest solution will be by factoring. Okay, so I place it here, z minus 2 times z minus 1. Or let's try to check the middle term if it's correct. The middle term will be minus 2z, and the product of negative 1 times z is negative z. A minus 2z minus z will be negative 3z. It is true. This is correct. The middle term is correct. The pure constant is just the product of negative 2 and negative 1, and that is positive 2. So it's also correct. So the possible binomial factor of this trinomial expression is z minus 2 times the quantity z minus 1, and this should be equal to 0. And equating its factor to 0, c1 will be equal to positive 1, and z2 will be equal to positive 1. So sorry for that one. So going back to the original substitution, z is equal to x squared. Computing for the value x1, we now put the subscript 1, right? Okay, so to compute for x, we must have to eliminate this 2 here. And to eliminate this 2, we raise both sides of the equation to the 1/2. So z1 raised to the 1/2 will be the square root of c1, and x1 squared raised to 1/2, these 2 here cancel with this. So it will now just be simply x1. So x1 will just be simply the square root of c1. It will be the square root. c1 is actually positive 2, this is positive 2, this is plus. Right? In the square root of a not exact radicand will still be a plus or a minus, it's not exact. So x1 will be plus or minus the square root of 2. Right? Again, by using a same equation, we what you call this? We replace the subscript instead of 1, it will be 2. We're solving for x2. And again, you raise this to 1/2. Okay? So z2 to the 1/2 will be the square root of c2. And x of 2 quantity square raised to 1/2. These two here cancel with this. So that will just be simply x2. x2 now will be the square root of c2. And since c2 is 1, what's inside is actually, this should be 1, right? Positive 1. And the square root of a positive number is either plus or minus. So x2 will be plus or minus 1. So the possible solution of the given equation is actually x1, two values, plus or minus the square root of 2. The other value will be plus or minus 1. There are 4 solutions because this is x to the 4th, right? Oh, that's the solution for example number 2. For example number 3, okay, solve the equation. We are given the quantity x squared minus 4 quantity square plus 5 times quantity x squared minus 4 plus 6, and this should be equal to 0. Okay? Okay, let's try to bring out the solution. We try to represent this portion here, our z. So we let z equal to the quantity x squared minus 4. So squaring both sides, z square will be c square, x squared minus 4, okay, to the second power will be x squared minus 4 to the second power. Okay? So, meaning to say, in the given equation, we replace this value here by z and x squared minus 4 quantity square by c square back here. So, substituting, I am still on camera. C square plus 5 multiplied by z, because this is z, plus 6, and this should be equal to 0. So after the substitution, what comes out is a quadratic equation involving z. Right? Because our topic is equation reducible to a quadratic equation. And if we try to bring out the simplest or the fastest solution of this is again by factoring. Okay, it will be the product of a two binomial c plus 3 times c plus 2. Now let's try to check the middle term. The middle term will be the product 3z. 3 times z will be 3z. Right? And 2 times z will be 2z. A 3z plus 2z will be 5z. It is true. The middle term is actually 5z. Oh, let's try to check the pure constant. The product of plus 3 and the plus 2 is actually plus 6. So we are correct. The possible binomial factor of this quadratic equation is the binomial z plus 3 times c plus 2, and this should be equal to 0. Equating its factor to 0, z1 will be negative 3 and c2 will be equal to negative 2. Okay? I brought out z1 equal to x of 1 square minus 4. Okay, since what do you call this? Since z is equal to x square minus 4, solving for x square will be equal to z plus 4, right? Is it correct? Yeah, c plus 4. But we must have to compute for x without the power 2, so we raise this to the 1/2. So x squared raised to 1/2, these two here cancel with this. So what remains will just be simply x. And z plus 4 raised to the 1/2 will be the square root of z plus 4. So if we are computing for the first value, this should be x1 and this should be c1. So I place it here, z1 or x1 will be the square root of c1 plus 4, the square root. So this should be negative 3 plus 4 Negative 3 plus 4 is 1. The square root of 1, it could either be plus or minus 1. Right? Second value, we will just use the same formula. We just replace the subscript. Okay? Because we are solving for the second value of x. So x2 here will be the square root of c2 plus 4. z2 is negative 2 plus 4. Negative 2 plus 4 is plus 2. It's a positive radical, right? So x2 now will be plus or minus the square root of 2. Okay? There are also 4 values because x1 is plus 1 and minus 1, 2 values, and x2 is plus and minus the square root of 2. Because this is raised to the second power. If you try to square, then raise it again to the second power, the highest power of x will be 4, right? So if we try to solve this one, there will be 4 values. x1, x2, x3, and x4. So this is plus or minus 1, plus or minus the square root of 2. Okay, that's it, guys. That's a good exercise for this Saturday morning. And we are now through with the solution of an equation reducible to the so-called quadratic factor. Okay? So for you guys who are studying college algebra or just reviewing college algebra or just scrolling up on the internet, on the YouTube by studying college algebra, this is for you guys. If you want to subscribe to my channel is at youtube.com/@prof.davidj.reyes. If you want to share it, please click here. I am telling you this one, okay? Try to watch my long video format discussion on college algebra. I will assure you, you will learn something from it because I am discussing concepts of what's coming out on these short videos. So if you are familiar with the concepts, you will solve the problems under short videos. Okay, for the speed. More exercise, more speed. So don't go speed. Try to go first with the concept before you could maximize your, what you call this, speed. Because we could not go speed without knowing the concept. Okay, good morning from Los Angeles. Professor David J.